All right, so I'm going to talk about doing little languages in Erlang. And the idea here is that you take some source that you define, and you compile that into Erlang Beam. And one of the Beam file, for those who don't know, is the Erlang bytecode format. When you compile a .erl file, it gets compiled to a Beam file, which is assembly instructions for the Erlang VM. The really cool thing about Erlang is most of that compiler infrastructure is done for you. So you don't have to take your little language all the way to Erlang Beam files, which would be admittedly quite difficult. All you really have to do is take it to one of two places. So I'll start by talking about how Erlang does its own compilation and how we can leverage that compilation for our own little language or our own DSLs. So when you compile a .erl file, a couple of things happen. The Erlang compiler takes that .erl syntax and turns it into an abstract syntax tree, a very high-level abstract syntax tree. This is called the Erlang AST. Now, in that high-level Erlang syntax tree, it does another pass on that compiler and takes it to something called core Erlang. Core Erlang is a much simplified version of Erlang. It's an extraordinarily simple language whose AST is very well defined and very understandable. Then from core Erlang AST, Erlang does a bunch of optimizations and a bunch of other stuff and takes that core Erlang AST through several passes of the compiler, several translations of that AST down to Erlang Beam code. So how can you leverage this? Well, you've got a couple of different points you can leverage. You can take your syntax and write a parser for it and take it down to core Erlang AST, and I'll show you an example of what that looks like. I'm sorry, take it down to Erlang's AST, and I'll show you what that looks like. And you can actually give that to Erlang forms 2. The Erlang compile with the function forms will take that core Erlang AST and produce Beam file output, either onto disk or into just into a binary if you want it to. There's a little bit of issue with that in that AST is a little bit more complex to write to. But you can also take your source compiler and compile that into core Erlang AST, and then, which is way simpler, and then let Erlang do all its optimizations and take that down to Beam file for you. Like I have a full-blown Lisp called Joxa that I wrote that basically takes the Lisp syntax and compiles that into core Erlang, and then it does a lot of its own optimizations to take advantage of the Lisp syntax and this kind of thing, and then lets the Erlang compiler take that from core Erlang down to the Beam file. So you get all the advantages of Erlang's compiling infrastructure, all of its advantages of its inliners and optimizers and all this in your DSL, and you have this relatively simple problem of just translating your language into that AST. I've actually got some helper functions that we're going to try and see if I remember how to use them. I think it's this. Actually. Nice source to core AST to Erl AST. Okay, cool.
You're not on this one.
Oh, hold on. Turn on display mirror. Should give us. Okay. Let's go to Erl AST first. Let's see if I remember how I did this. Oh, okay. Erlang string, I think it is. Sorry, guys, I haven't used these helper functions in a while. Let me see what's going on. If I can't show it to you, that will. Try this. I just wanted to show an example. Okay, I'll need to figure this out later. Let me do this. I can show you an example of core AST this way as well. To find a or Erlang AST as well. just giving something interesting here. I can't win for losing today. What's going on there? What's that? Oh, because I'm putting something that should. Oh, is that? I got 1 minute left.
That's 5.
Is it really 5?
That's 5, brother.
Okay, let's take